Welcome to another example of time value of money. In this example, we'll try to find out how to calculate deposits needed to accumulate a future sum. This is typically known as sinking fund. Now, typically in case of annuities, a fixed payment or receipt is made for a fixed number of years. In other words, an annuity can be written as rupees 200 per year annuity for 5 years at 5%. So basically, if we try to represent this on a time scale, it will be something like this. These are the number of years, and the annuity is 200 rupee per year. It can be at the beginning of the year or at the end of the year. We'll assume in this case it's at the end of the year. So 200, 200, 200, 200, 200. This is, let's say, an annuity in which we are depositing this 200 rupees at the end of every year at 5% per annum for the next 5 years. So I'll change this to negative sign, indicating that this is an outflow from our pocket. And in order to find out what we'll get at the end of 5 years, we'll find out the future value of this annuity at the end of the 5th year. So this is a typical case of an annuity where we know the annuity amounts for every year, and we'll find the future value in order to figure out what will be the value of the fund at the end of the tenure. Also, let's consider a case where this is a 200 rupee payment coming into our pocket. So we may want to find out the lump sum amount which, when deposited at 5% per annum, will allow us a withdrawal of 200 rupees for the next 5 years towards the end of each year. So typically in that case, for such an annuity, we'll try to find the present value. However, if we know the future amount and we have to find out the annual payments needed to make up the future amount, then it is known as a sinking fund. So consider another example. Let's say we know that at the end of 5 years, so the tenure is 5 years. So at the end of 5 years, we want to have the value of fund equal to 12,000 rupees. And let's say the bank pays 5% interest per annum. So in this case, we have to find out how much should be deposited at the end of each of the 5 years so that we get an amount of 12,000 rupees at the end of the tenure when the bank is paying 5% interest per annum. So how much is this amount? So this is a typical example of a sinking fund. From a calculation point of view, sinking fund uses the concept of finding out the future value of an annuity due or an ordinary annuity. The only difference is that instead of finding out the future value, we have to find out the annuity amount. So let us consider an example to understand this concept better. Your father has promised to give you rupees 1 lakh in cash on your 25th birthday. Today is your 16th birthday. He is trying to find out if he decides to make annual payments into a fund after 1 year, how much will each have to be if the fund pays 8%. So let's try to understand this on a time scale. So let's say this is your 16th birthday. Then you'll have your 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th, and 25th. Now, on the 25th birthday, he wants to give you 1 lakh rupees in cash. So the future value is equal to 100,000 or 1 lakh rupees. Now, your father wants to make annual payments into a fund starting 1 year from now, that is, starting from here. And the same amount he wants to deposit at a gap of every year. Now, if the fund pays 8% per annum, we are being asked to find out how much is this amount that your father needs to deposit every year. So let us look at the first method to solve this. So the first method is to use the formula for compounding. Now the first deposit that is made by your father in this fund will gain an interest of 8% up to this time, which is the 25th birthday. So if we consider this amount being deposited on the 17th birthday as PV, this PV will get converted into an amount. Let's say we call this as FV1. So this PV amount will gain 8% every year for the next 1, 2, 3, 4, 5, 6, 7, and 8 years. So n is equal to 8 in this first case. Similarly, the second payment being deposited on the 18th birthday will gain 8% per annum for the next 7 years and then give us an amount FV2 on the 25th birthday. Now the initial amount is the same, which is, we'll call it as PV, and here n is equal to 7. Similarly, for all the remaining years also we'll continue to get an amount FV. So we'll get FV3, FV4, FV5, and so on. And the sum of all these future values has to be 100,000 rupees. So in other words, the future value is equal to FV1 plus FV2 and so on up to FV9. Now we know that this FV is 100,000 rupees. Let's find out what these FVs will come out to be. So here each of these individual cases of FV1, FV2 and so on is a case of compound interest. So compound interest formula can be written as A is equal to P into 1 plus I to the power n, where A is the final amount, P is the initial amount, I is the rate of interest per compounding period, and n is the number of compounding periods. Now this can also be written as future value is equal to present value into 1 plus I to the power n. However, for all the FV1, FV2, FV3 and so on, since the annual payment is the same amount, the PV value is going to be the same. So this future value becomes PV into 1 plus 0.08 to the power 8, because as we saw, this first PV is going to be compounded for 8 years, plus PV into 1 plus 0.08 to the power 7, plus so on. Let me note down the value for FV8. So that will be PV into 1 plus 0.08 to the power 1, plus for FV9 it will be PV into 1 plus 0.08 to the power 0. So here we can take PV as common. So we get 1.08 to the power 8 plus 1.08 to the power 7 and so on, plus 1.08, which is this value here, plus 1. So anything to the power 0 is 1. Now the value of FV is 100,000. This is equal to the present value into the value of this bracket comes out to be 12.488, or present value is equal to 100,000 divided by 12.488, and this is equal to 8007.69. So basically, if your father makes a deposit of 8007.69 rupees every year starting from the next year, then at 8% interest per annum, he'll be able to withdraw 100,000 rupees on your 25th birthday. Now let us look at the second method, which is to use the formula for future value of an ordinary annuity. So the second method is to use the formula for future value of an ordinary annuity. Now why did we consider this as equivalent to future value of an ordinary annuity? So let's understand this. So here we were given that the deposit is being started from the 17th birthday, that is 1 year after the 16th birthday, and on the 25th birthday the future value or the total amount of the fund should be equal to 100,000 rupees. So if we consider the 16th birthday as year 0, 17th birthday as the completion of 1 year, 18th birthday as completion of the second year, and so on. And since the payment is being done on the 17th birthday, which is the end of the first year, similarly the second payment will be done at the end of the second year, and so on. So this typically becomes a case of ordinary annuity. The rate of interest is 8%, and of course the payments are the same for each year. So we can use the formula for future value of an ordinary annuity to find the annuity amounts. Now let's note down the formula for finding out the future value. So FV is equal to A into bracket 1 plus I to the power n minus 1 divided by I. Future value is 100,000. A is unknown. 1 plus I, now rate of interest is 8%, so 0.08 to the power n. So number of years in consideration is 9 minus 1 divided by 0.08, or 100,000 is equal to A into, so let's calculate this bracket value. So 1.08 to the power 9 minus 1 divided by 0.08 is equal to 12.48755. So we'll consider this as 12.488 into 12.488, or A is equal to 100,000 divided by 12.488. So 100,000 divided by 12.488. So 8,007.69. 8,007.69 rupees. So this is the same answer that we got in method 1. Now let's move to method 2, where we'll use the compound value factor of an ordinary annuity. So the third method is to use the compound value factor of an ordinary annuity. Now, as we had seen in method 2, we had used the formula for future value of an ordinary annuity, and this was the formula. Now, we also know that this portion is called the compound value factor of an annuity. So our formula becomes FV is equal to A into CVFA. Now here we know the future value and we want to find out the amount of annuity. So, or A is equal to FV divided by CVFA, which is also equal to FV into 1 divided by CVFA. Now typically this value here, 1 divided by CVFA, is also known as the sinking fund factor, SFF. Typically the value of SFF ranges between 0 and 1. So let's pull the table for CVFA. In our case, N is equal to 9 and I is equal to 8. So let's find out the value for CVFA. So as shown on the screen, this is the table for compound value factor of an ordinary annuity. The number of periods in our case is 9. The rate of interest per annum is 8%. So the value of CVFA is the value at the intersection of this row and column, which is this value here, 12.488. So let's use this value in our formula. So our formula was A is equal to future value divided by CVFA. So future value is 100,000 and CVFA came out to 12.488. So this is equal to 100,000 divided by 12.488. So 8007.69. So 8007.69 rupees. And this is the same answer we got in the previous two methods as well. Now let's look at the fourth method, which is to use a financial calculator. Now in order to use the financial calculator, we have to consider 5 key buttons. First one is N. N represents the number of periods, which in our case is 9. Next is I, which represents the rate of interest. In our case, it is 8%. Now, typically, while using a formula, we converted I into rate of interest divided by 100. So we were using 0.08. However, while using a financial calculator, we should enter the value as 8. Next is the present value, which in our case is 0. Next is payments, which is basically the annuity amount, which we want to find out. Next is the future value, which in our case is 100,000 rupees. So let's make sure that this sign is correct. So the future value is an inflow into our pocket, so this should be positive, so this is correct. Now let us use the financial calculator. So the method to use the financial calculator is, first we'll enter the value and then we'll let the calculator know what that value stands for. So 9 is the value of N, 8 is the value of I, 0 is the value of PV. Since we do not know the value of payments and that is the unknown, we'll click on that button towards the end. So let's first enter the future value, which is 100,000. Now we'll click on payments to find the payments. So here the payment is minus 8007.97. Minus sign is because this payment is an amount which is going out of our pocket because we are depositing this amount into a bank or a fund which is going to give us 8% over the next 9 years. So the amount of payments that your father needs to make every year for the next 9 years at 8% rate of interest is 8009.97 rupees. Now there is a slight difference in the decimal points in the previous methods, and that is probably because we rounded off to 3 decimal points in the previous 3 methods, while here we calculated the entire amount on the calculator itself. So you can use any of these 4 methods to find out the amount of deposit needed to accumulate a future sum.